Now, next we try to evaluate the indeterminate form infinite minus infinite. How to evaluate it? So, the process is, let f of x and g of x are two differentiable functions, are two differentiable functions. Differentiable means the derivative of given function is possible. That's called the differentiable. The differentiable functions and limit x tends to a f of x minus g of x provided the indeterminate form infinite minus infinite. Then what we will do? We will do like this. Then that function f of x minus g of x is converted to 1 upon g of x minus 1 upon f of x upon 1 upon f of x into g of x. Multiplication of 1 upon f of x into g of x. Here observe that the limit x tends to a f of x minus g of x provided the indeterminate form infinite minus infinite. It means that at the point x equal to a, f of x becomes infinite. Similarly, at the point x equal to a, g of x is also becomes infinite. Here observe that at x equal to a, f of x becomes infinite. Similarly, g of x is also becomes infinite. So, when we substitute x equal to a, f of x is infinite and g of x is also infinite. Here observe that 1 upon infinite is 0, again 1 upon infinite is 0, 0 minus 0 is 0. So, that numerator becomes 0. What about denominator? Here f of x infinite cross infinite is again infinite, 1 upon infinite is 0. So, that form provided 0 upon 0 form. So, that infinite minus infinite form is also converted into 0 upon 0 form and apply L'Hospital rule After deriving 0 upon 0 form, we can able to apply L'Hospital rule for solving this kind of limit. So, that regarded example is evaluate limit x tends to 0, 1 upon sin x minus 1 upon x. Try to solve it. Here solution. Here let us assume that L equal to limit x tends to 0, 1 upon sin x minus 1 upon x. Here we know the value of sin 0 is 0 and value of x is 0. Why? X tends to 0. When we substitute x equal to 0, we get 1 upon 0 means infinite. Here again 1 upon 0 means infinite. So, that will be provide us infinite minus infinite form. So, how to evaluate it? Taken LCM means cross multiplication of each 1 upon x. Here x is cross multiply with 1, sin x is also cross multiply with 1. We get limit x tends to 0, x minus sin x upon x into sin x into sin x. Then so observe that is the form of 0 by 0. When we substitute x equal to 0 in the given expression, we get 0 minus sine 0, and we know that sine 0 value 0, 0 minus 0 is 0, so numerator is 0. What about the denominator? Here 0, x equal to 0, 0 dot sine 0 is 0, 0 dot 0, 0. So that provided 0 upon 0 form. So L'Hospital rule is applicable. So according to Hospital rule, differentiate numerator and denominator for achieving the finite limit. So here differentiation of x with to variable x is 1 minus differentiation of sine x is nothing but cos x. Here x and sine x multiply together, so apply the multiplication rule of differentiation. So first one, x is as it is, take a derivative of sine is cos, plus sine is as it is, take a derivative of x is 1. So after differentiating the numerator as well as the denominator, we can put the in the given expression. Hence we get 1 minus cos 0, and we know that cos 0 is 1. So 1 minus 1 is 0. 1 minus 1 is 0. What about the denominator? 0 dot cos 0. Cos 0 is 1. 0 dot 1 is 0. Sin 0 is 0. 0 plus 0, 0. So again that will convert into the form of 0 by 0. Therefore again we differentiate the numerator as well as denominator with respect to variable x according to L'Hospital rule. So that gives us limit x tends to 0, differentiation of 1 is 0, differentiation of cos is minus sine, minus minus plus. So the plus sine x. Here upon again apply the multiplication rule of derivative x as it is, derivative of cos is minus sine and minus, plus cos is as it is, derivative of x with respect to x is 1, plus derivative of sine is nothing but cos. So that is cos x. And observe that here first we substitute x equal to 0 in the denominator, and observe that denominator is not equal to 0 or infinite, then we directly substitute the limit in the given expression. So here when I substitute x equal to 0 in denominator, we get 0 into sine 0, 0, cos 0 is 1, cos 0 is 1, so 1 plus 1 is 2. So denominator is finite, so we can able to substitute directly limit x tends to 0 in the given expression. So we get here sine 0 is 0 and denominator is 0 plus 1 plus 1. So by 2, and that is provided 0. So our limit L equal to 0. Then, so how we evaluate the limit as of the form infinite minus infinite, that is the way or procedure to evaluate the limit of the form infinite minus infinite. Next we observe that how to evaluate the indeterminate forms of the 0 raised to 0, infinite power 0 and 1 power infinite. So that all are the equal procedure to evaluate the limits of given indeterminate forms. So first we check that what is the rules and regulations and procedure. Let us see. Let f of x and g of x, f of x and g of x are two differentiable functions, and limit x tends to a, f of x power g of x, f of x power g of x provided 0 raised to 0, infinite raised to 0 and 1 raised to infinite indeterminate forms, 1 raised to infinite indeterminate forms then what is the procedure? The procedure is, then we assume that f of x power g of x is y. Assume that y equal to f of x power g of x. Both sides taking e. Remember ln means natural base e. Ln y equal to, according to the rules of logarithm function, g of x into ln f of x. G of x into ln f of x. Apply the limit both sides, we get limit x tends to a ln y equal to limit x tends to a g of x into ln f of x. ln f of x. So that is gives some finite answer like L. Say L. After evaluation of that limit, the answer will be denoted by L. And hence, according to the rules of logarithm and limit function, we get logarithm is outside of the limit and limit x tends to a y. Observe that our aim is to find limit x tends to a y. So here logarithm is goes to the outside, that becomes exponential. So that is limit x tends to a y is nothing but e to the power l. So that will follows that limit x tends to a, what is y? Say equation 1 or result 1. What is y? Y is f of x power g of x. So that is f of x power g of x is nothing but e power l. So that is evolution method of indeterminate forms like 0 raised to 0, infinite raised to 0 and 1 raised to infinite. So in this way we can evaluate the indeterminate forms like this. Say for example, we can try to evaluate example number 2, evaluate limit x tends to 0 sin x to the power 10x, sin x to the power 10x. How to evaluate it? Observe that solution is like that. Solution here suppose L equal to limit x tends to 0 sin x to the power 10x, sin x to the power 10x. And according to our procedure, we can assume that y equal to sin x power 10x. Assume that y equal to sin x power 10x. Then says equation 1. Apply logarithm both sides, we get ln y equal to 10x into ln sin x, 10x into ln sin x according to the rules of logarithm function. Apply limit both sides, we get limit x tends to 0, limit x tends to 0 ln y, which is equal to limit x tends to 0 10x cross ln sin x, 10x cross ln sin x. My dear friends, remember this limit x tends to 0 sin x to the power 10x is provided after substituting the limit x tends to 0 to infinite form, 0 raised to infinite form, because sin 0 is 0 and tan 0 is infinite. So here tan 0 is 0, sorry, sin 0 is 0 and tan 0 is also 0. Sin 0 is 0 and tan 0 is also 0, because sin 0 is 0 and tan 0 is again 0. Why? Sin tan 0 is nothing but sin 0 upon cos 0. Sin 0 is 0 and cos 0 is 1. 0 upon 1 is 0. So that is 0 upon 0 raised to 0 form. So we can try to evaluate it. Remember, our aim is to find value of L. Our aim is to find value of L. So that will be left hand side as it is, limit x tends to 0 ln y. Right hand side will be, here substitute x equal to 0, so tan 0 0, and here sin 0 0, and log 0 is nothing but infinite, so that is 0 cross infinite form, that is 0 cross infinite form. As per our earlier discussion, when any function or expression of the form 0 cross infinite, then we convert into either 0 by 0 or infinite upon infinite form. So that is limit x tends to 0 ln sin x upon tan means 1 upon cot. Suppose ln sin 0 0, that is infinite, and cot 0 is again infinite, so that is infinite upon infinite form, infinite upon infinite form, and that is 0 cross infinite form is converted into infinite upon infinite form. And according to the L'Hospital rule, it follows that limit x tends to 0 ln y equal to limit x tends to 0, differentiation of numerator is 1 upon sin x log y, that derivative is 1 upon y into derivative of y, so that is sin x derivative is cos x upon derivative of cot is nothing but minus cos x square x. Done? So that will be which is implies limit x tends to 0 ln y, which is equal to limit x tends to 0. Here cos x, I simplify that limit, cos x upon sin x, cos x upon sin x. Numerator is nothing but cos x upon sin x. What is denominator? That is minus cos x square is nothing but 1 upon sin square x, 1 upon sin square x. Then, so sin and sin from the denominator will be cancelled out, hence we get limit x tends to 0 ln y equal to limit x tends to 0 minus tends to 0 minus cos x into sin x, minus cos x into sin x, that denominator becomes numerator, cos x is there, multiply with sin x. So there is no denominator, then we can directly substitute the limit. So here cos 0 is 1, sin 0 is 0, 0 into 1 is nothing but 0, so answer is 0. So it will follows limit x tends to 0 ln y is 0. So as per our rules, the ln is outside of the limit, limit is applied on function y, which is equal to 0. So that will implies limit x tends to 0 y. What is y? Y is nothing but our assumption. What is y? Y is sin x to the power 10x. So sin x to the power 10x. Here ln is goes to the outside, that becomes exponential to the power 0. Hence we know that the e raised to 0 is 1. So our limit L is nothing but 1. So that will follows L equal to 1. So finite limit is 1. So in this particular way, we can try to evaluate that kind of indeterminate form, either 0 by 0, infinite raised to 0, and 1 raised to infinite. So there are several indeterminate form. Mainly we are discussing in our, as per our syllabus, we are discussing several types of indeterminate form. And remaining 2 types of indeterminate forms means infinite raised to 0 or 1 raised to infinite will be evaluated by this procedure. Follow the equal procedure. So I will depends that all two forms on U, and you will get the several exercises and examples in various calculus books. So thank you all of you for watching this video very sincerely. I hope you are learn lot of from the indeterminate forms or calculus portion in engineering mathematics. Thank you all of you. Thank you very much.